We have Ron. Is he coming? 1 second. There we go. I'd like to invite Ron Bonica up to talk about IPv6 fragmentation. We have the slides? Okay. There we go.
Let's see, which one's which?
Next.
Okay, green. Okay.
Thanks, Ron.
Hello, my name is Ron Bonica from Juniper Networks. This was initially scheduled to be a lightning talk where they invite folks to give good ideas or possibly crackpot ideas. This is my crackpot idea of the day. I'm here to talk about IP fragmentation and IPv6 fragmentation and why we should deprecate it. First, a little background. There's the status quo. Right now, when an IPv6 source node has a packet to send that is larger than the PMTU, it can fragment it and have the destination reassemble the fragments. In v6, only hosts can fragment a packet. That's different from v4, where both hosts and routers can fragment a packet. IPv6 fragmentation has always been discouraged. In fact, it's discouraged in RFC 2460. The reason why is reassembly is computationally expensive, it's inefficient, and there are security concerns, and there are other bigger issues that we like not to talk about in public. Let's talk about the security concerns first. The first is DOS attacks, and there are basically two flavors of DOS attacks that we've seen over the years. One is where the attacker sends fragmented packets to the victim, and he engineers this flow of fragmented packets to consume maximum resources on the victim's platform. Another flavor of attack, the attacker spoofs packet-to-big messages to the victim's legitimate communication partners. This makes the communication partner think that the PTB to the victim is small, and the victim sends, the legitimate communication partner starts fragmenting packets that don't really need to be fragmented. That's one kind of security concern. Another security concern that Fernando Gant has just pointed out is evasion attacks. Let's assume for a moment that you have a stateless firewall and it filters based on, say, IP source address and TCP port. Well, an attacker wants to evade that firewall, so what he does is engineers his packets so that the IP header is in the first fragment and the TCP header is in the second fragment. Every fragment evades the firewall filter. So, yet a new security concern. And now the problem that really bothers us. Implementations occasionally deal badly with some kinds of fragmenting issues. Fragment overlap, fragment override, overrun, too many packets being fragmented simultaneously. Well, yeah, these are all bugs, and good implementations deal with these, except when they don't. What should concern us all is randomly exercised code in the OS. So, these are all concerns about fragmentation. Well, we have some alternatives to IPv6 fragmentation. One bad alternative is just never send a packet bigger than 1280 bytes. This works in the vast majority of cases. In fact, I can only think of one case where it doesn't work, and that's where there's some middle box translating to IPv4. In that case, the middle box might send back a packet-to-big message with an MTU of less than 1280. Yeah, this works in most cases, but it's a hammer that's way too big. We don't want to do that. A better alternative, and this is the one that I'd like to focus on, is have upper layer protocols either execute path MTU discovery procedures or packetization layer MTU discovery procedures. Now, this just moves the problem of fragmentation and reassembly up from the IP layer to a higher layer. There's no such thing as a free lunch here. Somebody has to track the PMTU to the destination. We've just moved the responsibility, all the data structures, all the processing, just moved up from the IP layer to a higher layer. Many TCP implementations do this already. According to RFC 5405, UDP-based applications shouldn't send datagrams that are so large that they cause IP fragmentation. They should either look at the MTU information that the IP layer maintains, implement PMTU discovery themselves, or send only packets known not to exceed the PMTU. But in any event, well-behaved applications today do not send fragmented IPv6 packets. Now, what's the benefit of doing this? Well, again, we move the responsibility of fragmentation and reassembly from the IP layer to an upper layer. We're going to call that the packetization layer. It can either be the transport layer if it's TCP or an upper layer if it's UDP. This localizes the risk. If something goes bad, it affects fewer applications on the box. It also allows for layer-specific optimizations. For instance, TCP has mechanisms that it can use that are very effective for TCP transport. If an application knows perfectly well that it sends only short datagrams, it knows it can avoid the whole problem. So, let's discuss operational reality for a while. On the internet today, IPv6 fragmentation is extremely rare. Most popular TCP implementations already do PMTU discovery or PLMTU discovery. So TCP applications rarely emit fragmented IPv6 packets. Many UDP-based applications abide by the recommendations of 5405 already. They either send short packets or they do something to discover the path MTU. There are a few important exceptions. For instance, we know that DNSSEC can send large UDP packets. It does have a way to fall back on TCP, but I suspect if DNSSEC is an exception, there are other exceptions out there waiting to be discovered. And here's the bitter truth. A while ago, somebody talked about the Atlas, RIPE Atlas project. Someone did some study at NL Labs, and using those RIPE Atlas probes, looked at how many paths that would pass IPv6 datagrams would also pass IPv6 fragments. Well, what they found, of observed paths, 12% that would pass IPv4 traffic would not pass IPv4 fragments. So for IPv4, 12% of paths will not let fragmented traffic through. We have no idea why they're dropping fragments or where they're being dropped, although I suspect it's at the network edge, at the enterprise. For IPv6, the number was much more shocking. 40% of paths would not pass IPv6 fragments. So, my friends, if you're sending IPv6 fragments today, I wouldn't bet your house that they're getting all the way from end to end. Thanks to the folks who did this study, there's a reference to their paper at the bottom. So, where does this leave us with a recommendation? In a few days, you'll see a draft posted to 6man. It will recommend the deprecation of the IPv6 header. Now, what does that mean? Applications, please don't write any new applications that fragment IPv6 packets. Existing applications will continue to work. This is just deprecation. They will work as well or as poorly as they do today. The draft will also state that operators may discard packets containing the IPv6 fragment header. And this shouldn't shock everybody because operators already do discard packets containing the IPv6 fragment header. I'm coming here today so that when the conversation comes up on the six-man list, hopefully all you folks will chime in and either support the position or burn me at the stake. Thank you very much.
Hopefully no burning at the stake, but we do have a few moments for questions. Just of note, there's no microphones along the outside, only down the center, so feel free to bump into your neighbor on your way out if you've got any good questions to ask. Anyone? Okay. All right, thanks.